Hello everyone. Today's topic is filtering of long data sequence. Now, what does it mean? Uh, it may happen that in practical application, uh, in case of filtering, uh, filter may have to handle a long data sequence because what is the data coming towards the filter, it doesn't know, and it may be a long sequence and it has to perform frequency response. Filter is performing frequency response. That means it is performing DFT. Now we know that in case of DFT, it is actually performing on a block of data 0 to n minus 1. That means n block of data. So that means the block of data is having a limitation in size. So, how a long data can be transformed or can be processed so that we can get the output. So here linear filtering is done. Now how linear filtering is achieved? Because when there is a filter and it is getting the output, filter is having its transfer function, and the long data sequence will interact with that filter system and it will generate the output data. So that means it is causing linear convolution. So now if there is a long data sequence, how can we get the output part using DFT in computers? What are the methods it used to take? Today we are going to learn. Now, what is the procedure? The procedure is if the data sequence is very long, we have to segment the data sequence. And from the segmentation, how we have to arrange the segments and how we have to input it into the computer, there is an algorithm or a logic. And this logic is generally performing in two ways. One is called overlap save method. So this filtering of long data sequence is done in two different way. First one is overlap save method, and the second one is overlap add method. In both of the methods, the long data sequence is actually segmented. In both of the methods, the long data sequence is actually segmented. Suppose we are discussing about overlap save method. What happens? This data, first think of the data. Suppose I have a long data sequence, this much of long. I have the filter which is having the sequence of m length. The filter is having, or the system is having, sequence of m length. Now what I am going to do? I will obviously take this. I will obviously take the input data in L number of segments. I will divide the input data in L number of segments. Okay. I am taking it. I will take the data and divide it L number of segments. And how overlap save method is actually we can perform overlap save method and as well as overlap add method. And how we are going to take the sequence data L number of data. In case of overlap add method, we are going to streamline, or we're going to arrange L number of data in a certain manner. In overlap add method, we are going to arrange this data in another manner. And then what we do, we suppose this arrangement of the data sequence is suppose x1n. So there is a sequence of x1n such that this length will be of L plus m minus 1. Now how this arrangement is performing, it is having a syntax in overlap add method and another syntax in overlap save method. But the thing is same. We are going to make a input sequence which is having a length of L plus m minus 1. With second segment data, similarly we are going to perform x to n, and it is also having L plus m minus 1 data. Then what we are going to do, we are going to multiply each and every segment with circular convolution with the filter sequence, suppose Hn. And we will get the result y1n. Similarly, we will get result y2n. And how if it is up to 3, we will get the result up to y3n. And how we are going to arrange y1, y2, y3 in overlap save method and overlap add method, we will going to see. So each and every method I am going to discuss in different videos. So up to this, thank you for discussion on overlap save method. We are going for a next video.